This video is about how to do chi-square tests for one-way designs in PSPP. Now in the one-way design we just have one variable and we compare how the observed count in this variable matches the expected count. An expected count is the frequencies in each category. They don't have to be the same, but sometimes they are. For example, for a dice, you have 6 categories. For each face of a 6-sided dice, the probability is exactly equal. So there you would expect the same count for each category. But sometimes you have different expected counts for each category, and then you would adjust to that. So let's go to PSPP, and we're choosing the variable SES. What we want to see is if the socioeconomic status, if that is equally distributed. There's 3 categories, 1, 2, 3, which 1 is low, 2 is medium, and 3 is high. And now we're assuming that the probability to be in each of these categories is equal, and want to test if actually our assumption is met that these categories are equally distributed. So again, we go in our menu Analyze, and for the chi-square you go almost to the very bottom here to non-parametric statistics, and right, because chi-square is part of the non-parametric statistics, we click on chi-square, and this is where you have the menu for the one-way designs. So again, we choose our variable and click it over. So we're going to test this variable SES, and if you're expecting for each category the value to probability to be equal, then we just leave it like that. All categories are equal. If you would expect different proportions for each category, you could do this, and the values that you're going to input here will be the percentage for each category. And we'll do an example like that. So let's just do the normal one. All categories equal. Hit OK. And now we see the output. So we see observed. We see 62 students in low status, 48 medium status, and 57 in the high status. That's what we observe. And what we expected, the frequency we expected was actually 55.67. How did we get this? That was simply the total number of students divided by 3 for each category, and so the average for each category was 55.67. The residual is the difference between what was observed and expected. So here we have 62 minus 55.67, so we have 6.33 more than we expected. In the next category, the medium, we observed 48, but we did expect 55.67, so we have 7.67 people less than we expected. And then for the high status, we observed 57, we expected only 55.67, so we have a little bit more, 1.33 more than expected. And then based on that, we get the chi-square, which is 1.81, the degrees of freedom, which is 2, and the significance level, which is 0.40. Since it's bigger than 0.05, we retain the null. There is no difference between the observed frequencies and what we expected. So the conclusion is there's no difference between observed and expected. These frequencies here are not significantly different than what we expected. Now, just to give you a quick insight in Excel, the way we've used to do it, right? In Excel, we had the observed frequencies here, then we have the total calculated here, then the expected proportion was 0.33, right? 1 divided by 3 categories, so 0.33 for each of these categories. Now the expected frequency, so for 167 times 0.33 is 56. Now this is because of rounding. If we go here, we actually get the same 55.67 that we've seen over in PSPP, right? So this looks the same. Now the residual, same, right? Observed here minus expected, so you get that for each cell. Now we're gonna square this, and then we're gonna divide these 40 by what we expected, right? We're gonna see how much, compared to how much we expected, how much did we deviate. So this is the deviation, the chi-square here, and if we add this up for each of the categories, we get a total chi-square of 1.81, which is what we got from PSPP as well. Okay, so this was the one-way design chi-square test.